Section 4.3, Modeling with Exponential Functions, Part 1. A certain culture of bacterium initially has 25 bacteria and is observed to double every 5 hours. Find an exponential model for the number of bacteria in the culture after T hours. Estimate the number of bacteria after 18 hours. After how many hours will the bacteria count reach 1,000,000? Let's look at the model that they want us to find. They want us to find the model NT equals n sub 0 2 raised to the t over a power. What makes applications much easier to work with is when you can take a few minutes to look at what your variables represent, tie those variables to problem information, and it helps you set up applications much easier. Okay, so we are given that the initial size of the population is n sub 0. Doubling time is A. The size of the population is NT. That's the formula that we're working with. And time is T. A and T are measured in the same units. So if we're given doubling time is in hours, then time T must be in hours. If doubling time is in minutes, then time T must be in minutes. The measured units are the same. Okay, so now let's go back and look at, now that we understand what our variables represent, let's go back and see if we could plug in some numbers. A certain culture of bacterium has an initial 25 bacteria. Initial, that must be n sub 0. So we're going to plug in 25 for n sub 0. It's observed to double every 5 hours, and that's what A was, double time. So double time every 5 hours. So for part A, we want that exponential model. So n sub t is equal to n sub 0, 25, times 2 raised to the t divided by A, which now we know is 5. And there's our model. Estimate the number of bacteria after 18 hours. So that would be when time is 18. So we're going to say n of 18 is equal to 25 times 2 raised to the 18 over 5. Okay, so let's get that put into our calculator. We have 25 times 2 raised to the 18 divided by 5, and we get about 303.14 bacteria. Okay, for part C asks after how many hours. So in words, that would be find T. After how many hours will bacteria reach a count, so that's n sub t, of 1,000,000. Okay, so the count is 1,000,000. N sub 0 is still 25. We still have 2 raised to the t, because that's what we're looking for this time, after how many hours. So we're looking for t. T divided by 5, which is still our A. Okay, first thing that we're going to do is we're going to take that 25 and we're going to divide over. 1,000,000 divided by 25. 1,000,000 divided by 25 is equal to 40,000. Now we have an exponential function. How do we know we have an exponential function? The variable is in the exponent. How do I undo an exponential? I undo an exponential with its inverse. What's the inverse of an exponential? A logarithm. Now we're going to have to use our calculator to calculate, so we're going to logarithm both sides, but we're going to choose a base that our calculator does. We're either going to do base E, ln, or we're going to do base 10, log. We're choosing these bases because I know I'm going to have to plug this into my calculator, and so I want to be able to use one of these two bases. It doesn't matter which one you choose. I like ln, but if you like log, you would log both sides. If you like ln, you would ln both sides. So we have the ln of 40,000 is equal to the ln of 2 to the t over 5. Now, it didn't seem like that helped much, but it did, because now we can use law number 3 of logarithms. Law of logarithms says if I have an exponent, we can write the exponent out front. So we have the ln of 40,000 is equal to t over 5. Our law of logarithm says we can bring down an exponent. So we have t over 5 ln of 2. Once we use that law, we can see now it's going to be very easy to solve for t. We'll first multiply over that 5. So we've got 5 ln of 40,000. And we'll also divide by the ln of 2. Once I divide by the ln of 2, then I have t. Okay, so let's get that put into our calculator. Okay, so we have in the numerator, so I'm going to use a set of parentheses to make sure this entire thing stays up top. Ln of 40,000 times 5 divided by the ln of 2. And we get 76.44 if we round to 2 decimal places. 76.44. Now, time was in hours. So after 76.44 hours, we'll have 1 million bacteria.